There you
There you
go. Thank
go.
you.
All right. Hello. I'm going to talk to you today about how you can build a security program that scales better than linearly by defining secure defaults and then leveraging modern frameworks and lightweight static analysis tools to enforce them. So first of all, a bit about me. Here's a picture of actually me. My name is Emma Jin. I'm a program analysis engineer at RTC. I graduated from Carnegie Mellon University with a bachelor's in computer science. You might notice that I'm not a security expert. I work in program analysis, but I'm really excited about how we can most effectively use static analysis to better security. And also as a developer at a company that does use security defaults, I have a sense of what it's like to be on the other end of that pipeline. And then a bit about my company. It's called RTC, of course. And we're a static analysis startup based in San Francisco, whose mission is to profoundly improve software security and reliability. So in service of that, today I'm going to talk to you about security defaults. First, I'm going to posit that bug finding isn't the answer. And then hopefully having convinced you of that, I'll explain like high level how you can build a program to eradicate vulnerability classes and then go into some tools and techniques to make it real. So to start, why bug finding isn't the answer? There have been some pretty significant shifts in tech and security in the last few years. On the tech side, like obviously we've gone from waterfall development to agile development. Also, we've gone from separate dev and ops teams to like combined DevOps teams. We've gone from running our code on premise to in the cloud. And in security, we're moving from finding vulnerabilities to defining secure defaults and invariants. So as an example to like motivate why we want to do this, here's an example of a question that security teams need to answer all the time. Does this app have XSS? And this is a pretty difficult question to ask. And it's hard because this is actually a lot of different questions. You need to know, what does the user control? Is the input filtered? How is it stored? Is data processed before being sent to the user? And these are all not easy questions to ask. But we could actually ask an easier question. Let's say we had some information that this app was written in React, and we then wanted to know whether it had XSS. So this doesn't seem like an easier question on the face of it. I haven't given you any information like about what the user controls or is the input filtered or whatever. But actually, this is a somewhat different question, which is simply, does this app use dangerously set inner HTML? If it does, then it's likely vulnerable to XSS. And if it doesn't, then it's likely not. And of course, this isn't like a hard and fast thing. Like there are edge cases, and also there's always the possibility that React has a bug. But React is a well-defined framework that many people use, and it's well understood. And so you can get rid of a huge potential for XSS simply by banning dangerously set inner HTML in your code. This isn't like a presentation about how to stop XSS using React, but this example shows what we want security to move towards. It shouldn't be about asking all of these questions. We should have secure APIs such that once those secure functions are used, we know the app is safe. And this is hugely important because this allows security teams to better leverage their time. Like a security team needs to do a lot of things. There's threat modeling, running security tools, looking for XSS, looking for SQL injection, more stuff. And if we can just kill like a large chunk of potential XSS bugs and never have to find them again, then we can do the same for SQL injection. Suddenly there's so much more time for the things that really need the security team's expertise and time, like threat modeling, security training. So ultimately what I'm arguing is, instead of finding every vulnerability, the first thing security should do is try to prevent classes of vulnerabilities using secure defaults. Now, at this point, you might be saying something like, okay, that sounds great, but all you show me is some hand-wavy diagrams and tailored examples. Like, the security industry has been focused on bug finding for decades. Really smart people have written really awesome tools that find like null pointer exceptions and memory errors. There's like an entire bug bounty industry, and that's for a reason. And like, while the security default stuff sounds good, it ultimately needs developer buy-in, and developers aren't exactly thrilled when you tell them to change how they code. So I'm glad I can tell you that this isn't just like the brainchild of a bunch of program analysis and security researchers. It's been deployed in actual large companies. For instance, this is a slide from Netflix's presentation in 2018, where they talked about how they were de-emphasizing manual testing and traditional vulnerability scanning in favor of using paved roads, which is another way to say security defaults, and killing bug classes. And Microsoft has, in fact, implemented some of this so we can actually quantify whether it works or not. Microsoft decided to ban string copy, which if you've done any C programming, you know, is a rather problematic function, and the rest of that family, and instead developed their own safe libraries for copy that wouldn't be, you know, you don't have to like add your own null terminator at the end. And in an analysis of 63 buffer-related security bugs in Windows versions before Vista, they found that 41% of those were removed just by banning the APIs, which is a significant amount. So you might ask, like, okay, so you've banned string copy, but what if someone wants to use it? Basically, like, we're arguing they just shouldn't. Of course, string copy can be used safely. I've used it. I hope I've used it safely, but it's not easy. You know, you have to make sure you've allocated enough memory, then you have to make sure your string is null terminated, and reasoning about both of these things is error prone. It's just not worth it. Like, you might notice that I called string copy a problematic function rather than a vulnerable one, because it's not inherently vulnerable, but it can be. And there are other functions that won't be, and we should always just prefer those instead. Developers don't have to use this possibly vulnerable function. Essentially, there are just so many functions out there that you have to think about. And for a developer to be an expert on all of those subjects, to understand all of this stuff is unreasonable. And also for the developer to always be maintaining vigilance when they're writing their own code, for the reviewer to never be tired and miss something when they're reviewing code. There are new developers, like your new hire who's only done C in like one class in college maybe, or like an older, more experienced developer who's transitioning from another language, and they need to be brought up to speed. And it's very easy to make mistakes when you're just learning. So a better approach is to use common frameworks, languages, and libraries that make writing code with common classes of security vulnerabilities impossible. Of course, you know, in the case of that new hire, we can train them. But based on experience, we know that this is not enough. Microsoft has spent a lot of money trying to improve its security, and they've found that tools and guidance are demonstrably not preventing memory safety issues, because memory safety issues had represented almost the same proportion of vulnerabilities for over a decade. So what we're proposing is not to like throw away all of those really cool, you know, tools and bug bounty programs and all that. That's still necessary. But what we're arguing is that the first thing, part of the security pipeline, is to have libraries of code and new programming languages that prevent common classes of bugs, and then which then leaves more time for the security team to focus on the hard bugs, the new bugs, threat modeling, things that are more interesting and difficult instead of the same bugs that we already know about. You might point out that it's not exactly easy to just write a secure programming language. And fortunately, in this day and age, we don't have to. There are a lot of secure frameworks out there. There are secure programming languages that have been developed. And so it's what the security team needs to do is just understand those frameworks, understand which functions are vulnerable, whether deliberately, like dangerously set HTML, which is provided as an escape hatch, or by accident, if there's a mistake, and to be able to mitigate problems from those so that they won't keep showing up. So now we're going to get into like a more high level explanation of how to actually eradicate vulnerability classes. There are basically four like broad steps. First, you want to select a vulnerability class. Then once you've understood that vulnerability class and how it appears in your code, you want to select the safe pattern, make it the default, then train developers to use the safe default, and finally actually enforce the safe pattern using tools. Selecting a vulnerability class, you probably want to do in some sort of like structured way. There's just so much stuff to do out there. And so you might want to choose maybe like the one that's most prevalent in your code base, or maybe you want to go for like something that doesn't occur as often, but if it happens, it's really bad. Or maybe you just want to start with whatever's easiest to tackle. But whatever it is, you'll probably end up using some combination of that. But whatever it is, you will need information. So it's important to be tracking your vulnerabilities as they come in. It's not every company has such a program, but to know both your current state so you can figure out which vulnerability class to start with, and also to understand if your future efforts actually work before you spend weeks or months working on this. It's important to track some information. So generally, this is like what we've found is important to track. You want to know like what kind of a vulnerability it is, the code that caused it and fixed it, how how likely it is to be exploited, how bad it would be if it were exploited, and so on. And then once you have that information, it's very easy to build a list of prior vulnerabilities that you can review to choose a class. If you don't have that already, you can also use you can filter all of your GitHub issues tagged security, or maybe you can create a list of security related keywords like XSS and just find all of those vulnerabilities to create a data set. But that'll allow you to sort your vulnerabilities by class. And then within each class, ask like, does the vulnerable code look similar? Is the root cause the same? Are the functions, is it always just calling is it always traced back to one bad function call? And then it'll be easy to figure out what the safe pattern is. The perfect vulnerability class is like widespread, high risk, always broken in the same way. That's definitely ideal. If you can just make a simple rule to ban it forever. And also like, it's important that it's actually feasible to get devs to fix it. So they actually care about it. And the fix is simple enough, because at the end of the day, this requires developer buy-in. Probably you will not find a vulnerability class that fits all of these, so you'll need to know your own priorities. But whatever it is, just pick one, and then we can start eliminating it. So the next thing has two parts. So first, you want to select a safe pattern. This is based on your own expertise, your company's expertise, its internal coding guidelines, and also all of the research security people have already done. There's the OWASP cheat sheets, for instance, which is a great resource for what to do to make things safe. And then making it the default is really important and takes a bit of work. It's not just enough for the pattern to be more secure. No developer wants to write 5 lines of code when they could have written 1, which is why I personally don't use try catches nearly as much as I probably should, because it's ugly. So for your pattern to be adopted, it needs to not only be more secure, but also just better to use. And so one thing you can do is build a secure library and just include it everywhere. so that developers have functions they can draw on, which have good APIs, so that they can call whenever they need to do something. Also, it's important to think about like with leveraging the existing developer tools out there. Like for instance, if there's a new project starter template and it includes something that's insecure, that's going to just be a problem forever. So prioritizing those things, a new project starter template is a very important place to make things secure versus maybe something further down the line. And then update all internal coding guidelines, which is always like more of an effort than you might expect because there's just so much out there. There's readmes and documentation, and there's training slides and onboarding presentations. And then kind of related, you need to train developers to use the safe pattern. So it's really important to convey to developers what and why something is insecure, and then how they can fix it. Developers want their code to be secure too. Like everyone understands that security is important, but when you're rushing in a commit, like at the end of the day on Friday, so that you can just like end the day, and you get an error message, and your pre-commit tells you like this isn't secure. It's frustrating to have to figure out what you actually need to do to fix the problem. And so ideally, you could even like the best case is if the developer can just click a button and their thing magically becomes the secure version. This is possible in some cases. It's not always easy. But however vulnerabilities are communicated, it needs to be very clear what is being insecure, why this thing is bad, like why they should care, and then how they can fix it. So here's a nice template for in documentation, what to include. So I personally think that like the comments given by tools are, since those are the most immediate place where developers see problems, that's the best and most important place to put the messaging. And also engaging with developers. There are a lot of options for this. There's onboarding. You can also lead educational brown bag sessions. You can like have candy on desks by a security team so that people will come over and you can chat. But the important thing is developers need to believe in secure pattern, in your secure defaults, because if they don't, like ultimately every tool has some sort of escape, like there's always a way around these tools, and developers need to want to work with them. But after developers believing that, you need to you want to use some sort of tool to enforce the safe pattern, so that because everyone makes mistakes, we don't want those mistakes to get into production. The great thing about these patterns is, unlike a null pointer dereference, which is very difficult to find and requires doing complex like interprocedural analysis, the patterns we're talking about are really simple, like searching for all uses of dangerously set inner HTML. You could even do that with grep. And so this kind of linting is very lightweight, it's very fast, and so you can get immediate results back to developers. Cool. So that's an overview of how to build a program. We're going to talk about some tools and techniques to make it happen. In particular, we'll talk about like the second and the fourth bullet points here, and then mostly the fourth, how we can set up continuous code scanning to actually enforce the safe pattern. There's been a lot of work done on continuous scanning. Here's a bunch of links. Here's some more links. In the next few slides, we hope to just summarize the learnings from all of this research. So some best practices: we want to scan pull requests. And so if people violate security defaults, it should block. Their code should not be able to be merged so that you can't get insecure code in production. It needs to scan quickly. So sometimes it might make sense if you have some slower rules to not include those in the pull request scans, but leave those for on a daily or a weekly cadence, so that you still get the information without annoying developers. And you need to make adjustment easy. If people start using Django and you want to add rules for that, then that should be easy to add. Also, if you find that developers aren't fixing an issue, or if developers are finding that this rule causes a lot of false positives, they should be able to remove it, or you should be able to make the rule better. Because if your tool is always triggering on things that developers don't consider issues and don't want to fix, they would want to just turn off the tool. Developers need to feel that the tool is helping them, and they will if it's catching issues they care about. You often might want to have two scanning workflows. In fact, a blocking one for issues that are, when you have rules that are high signal and that are serious issues, to block developers from merging, like just fix this now, versus like an audit scan, which is just for the security team's visibility so that they can understand. Maybe they're testing out a new rule, or maybe they just want to understand like the prevalence of something. You need to scan quickly. And by quickly, I really just mean that you shouldn't come in last. If the build tests take 26 minutes, nobody's going to object to the security checks taking 25. But if the build tests take 5 minutes and the security checks are taking 25 minutes, people are going to be annoyed that they can't merge because of their security checks. Ideally, this should be reported as early as possible. Pull requests pull requests is pretty good. People are used to having their pull requests being reviewed. They should be making their pull requests quick in like short chunks, so that they're easy to review. And so the context should be pretty fresh when they see those comments. Certainly, if you can have it in an IDE, that is the earliest possible you can surface information about the issue. But even if you're reporting it early in like VS Code, say, you still want to enforce it in CI so that they can't ignore it. They can't just like look at the red squiggly and ignore it. I will get to questions later. And then in terms of displaying results to developers, we just want to follow the findings that the principles we talked about earlier. Making it clear, making it actionable, using only very high positive checks. And you probably want to capture your own metrics about the check types, how long the scan is taking, what the false positive rates are, so that you are proactively keeping track of how effective your rules are. And if possible, just like include a suggestion for how to fix. Even an imperfect suggestion gives developers an idea of what to do, and they can change it based on what they need in their own code. In terms of what to look for when you're doing continuous scanning, if you have a secure framework, this is easy. All you just have to do is detect like whatever functions there are that let you escape from the invariants. So in our previous example, dangerously set inner HTML. You might need to do some research into what vulnerabilities are possible in the framework. And if you aren't using a secure framework, you might have to do some more work in defining one. And then in terms of what you can use to find them, we've mentioned earlier that like if you have something like dangerously set inner HTML, that can be found with grep. You don't need anything fancy. The name is long enough and distinct enough that you can just look for all instances of that string. You might want to have a code aware linter. This is nice because, if you have something in a comment, it's not going to find it. It'll understand white space. But on the downside, each parser represents ASTs differently, and you have to learn the syntaxes, unlike grep, which is regex based. Let me see. I see there's a question. Isn't it possible if the code has APIs for other programs in the app that a recognized bad module could break the API when the code is fixed? That could break an app that's worked for quite a while. I think, is this asking like what to do if you import a bad module, or something different?
Hey, Bill, feel free to unmute yourself and clarify if you can.
Oh, like you fix the bad module and then something else breaks. I see. So, I mean, so there are two different things you can do in this case. You might want to, like, if possible, if you're breaking other stuff by fixing a security issue, like, I guess, try to not, basically, like, try to replicate the original functionality as best as possible. But every linter you use should always have like some sort of ignore this specific instance. And so if you feel like the module is being used in a way that wasn't actually insecure and that you can't replicate this functionality otherwise, you should probably just ignore, like just add some kind of like ignore this particular line, but still flag the module so that like uses of it that are insecure get caught. Does that help? Awesome. So in this last part, we're just going to talk about what we do at our company. We make SemGrep. It's a brief overview. This is kind of like the features of SemGrep. It's open source. It supports a lot of languages. It does not require your source code to build. So it's kind of in between grep and a more, and like some fancier tool that requires your code to compile. And so as a reminder, here are the steps for how to eradicate vulnerability classes. We'll just go through what we did for each one of these. First, when we selected the vulnerability class, RDC even now is pretty young. I think we just turned 4. But when we started making our program, we didn't have very much vulnerability history. We had 2 primary code bases, one for the web app, one for the command line agent. So we decided to prioritize based on common problems for the type of application we had. In the case of the web application, we knew XSS was a big problem. For the command line interface, code and command injection were important. So we started with those 2. So for XSS, our backend was in Flask and our frontend was in React. We've already talked about React and how one of the main, like a very large class of XSS is caught by just banning dangerously set inner HTML. So that was easier. Flask was a little more complicated. We actually defined an entire policy because there were multiple ways to have XSS. And you'll notice that a lot of these recommendations are very simple. Instead of using render template string, just use render template. That's a great kind of recommendation because you can, that's even something that can be done automatically. We have an autofix feature in SemGrep, so you can just click a button and it will change your render template string to render template. But then some of these are more complicated, right? I think this kind of gets into Bill's question. Like one of our mitigations was just ban markup. sometimes you need markup. And so our recommendation was that this should be banned, but if you feel that you really need this, send it to the security team. And they review each usage, and then they can choose to exempt it with no sim. What we aren't doing is saying, okay, markup is sometimes necessary, so we should let it through and review continuously, because odds are people are going to use it incorrectly. And the cool thing about defining these rules is that they can be shared. They've been codified, so they can be shared. And because our tool is very community-based, we have rule sets that anyone can use to ban accessing their own apps. For training developers to use the safe pattern, we relied a lot on our PR comments, and also having it in the whatever the developer uses to write code. So we have SimGrip policies. The very fastest ones are in our editor plugins. Most people use Vim and VS Code, so that's where we have them. And then we put some slower ones in pre-commit, and then most of our rules are run in GitHub Actions, so that a lot of issues can be caught like even as soon as the developer types them. But then some rules are a little slower. They're looking for more things. Maybe they're doing some like imitation of taint analysis. And so that goes in the GitHub action. And we make sure to include a dashboard so that we can see what's happening. We include a fixed rate so that we can see how often developers are actually responding to these rules. And we track that because if developers aren't fixing their findings, they might as well not be seeing them at all. And seeing them will only make it, seeing them is actually detrimental because they'll get used to ignoring the reports from the tools, and we don't want that. And then as a bonus, we write new policies, and then we just deploy them quietly, non-blocking, and we monitor them to see how well this rule set is performing, to check for ourselves whether they're giving too many false positives before deciding whether or not to deploy the rules. So in conclusion, I hope I've convinced you that secure defaults are the best way to scalably raise your security bar. In summary, if you have a vulnerability class that you are aware of, once you define a safe pattern, you roll it out and enforce it continuously, you can make sure that the bugs you're aware of will never be seen before. There will always be new bugs. There will always be things that are hard and that can't be caught using secure defaults. But this way, you won't have to worry about the things you already know about, and you can focus on those new and harder problems. Any questions?
Sorry about that. Do we have any questions that are going on for the presentation for Emma about SimGrep or any of the other areas she covered?
So I have one. So this is an open source, a free tool, right?
Yes.
How does your company make money then?
Our company creates, so what I showed here, this is SimGrip app. So I think we follow like SimGrip as a service for our paid plans, and you get like all of this other stuff, information that you track issues. Yeah.
I got your model, but anybody can use the tool on their own free. Yeah. Cool. Thanks.
Oh, I see. How do you learn about the new bad practices? There are different ways. So like if someone reports a vulnerability, like, you know, if you get a bug bounty, that's a really easy way to find a new bug. Oh, access is denied. which link? Is it the web assets one?
Yeah, it is actually. Matt, I did the same thing, Matt. Yeah.
Let me check that real quick. Yeah, so back to the bad practices question. Yeah, if someone reports a vulnerability, that's obviously a way to proactively look for new vulnerabilities. I mean, this is back to like, we want to coexist with we're coexisting with other methods we already have. So pen testing, if you're using other security tools that can be run on maybe like, if they're very slow, they can be run on a daily or weekly basis, but they'll still surface vulnerabilities to you that you can realize, oh, this is a different way to get memory access error. Maybe we can look at what code caused that and see if we can define a pattern to prevent this. Oh, new bad practices in the world. I guess going to meetups like this, reading, like just following along with what's happening, and also like keeping track of what your company's code base is using, and following along with like what vulnerabilities are possible with those frameworks. Ooh, contributing rule sets. I've codified rules in other formats. How easy is it to codify my company's rules in SEMGREP? That's a great question. So I think SEMGREP is extremely intuitive syntax. But this is a question you can decide for yourself. Let me see if I can get an example of a SEMGREP rule. I don't think we have one here. SEMGREP.dev. So our rules look like this. Let's see, playground. So as an example rule, if you want to search for all instances of exec, you just have to you just write exec and then you use dots to indicate that you can have any arguments, and that'll catch all of these instances. There are some more complicated rules, like this is an example of explaining that you have to call verify before you make a transaction. So the dots just mean like you can have anything as long as the verify transaction shows up before the make. Does that make sense?
Yeah, what I was trying to get a picture of how hard is it to contribute and do, how often you see third parties. I see a few people contributing rule sets. I'm just trying to gauge how easy this is, how often you're seeing people contribute this. Is this expert groups, or do you see companies diving in and contributing rule sets? Because reuse of rule sets is probably one of the fastest velocity pieces here. What I'm running into exhaustion with my teams are hey, one rule set's in one language format and another. It makes it our difficulty to try to make sure those rule sets are kept up and working. So I'm just trying to get a picture of how easy it is to contribute into this ecosystem and its direction. Love the tool, by the way. I'm just weighing that that balance on that for the developer and the build ecosystem. I was about to ask a follow-up question, where you see yourselves in the future going into, not just beyond the build and static analysis, but also marrying that with the operational check, because the hardest thing is having a rule that I have to rewrite twice, one to check in one environment in the operational environment and one to check in the build, but I'm trying to get after the same problem. So I was just interested in the contribution and the ease of it and all that.
We have like a good, I suppose I don't necessarily keep track of the expertise of all of our community contributors, if that makes sense. Like my anecdotal experience is whenever I hear, like I see a news report that's like, there's this vulnerability, someone says, hey, I've written the SEMGREP rule for it, which is really cool to see. And so it seems like it's pretty easy to contribute community rules. And also, if you don't want them to be community, you just want like that for your own company, you can have private rule sets. So yeah, I think it's pretty easy, but that's my perspective as a program analysis engineer. In terms of where I see the company going, I think increasingly I keep seeing people like just voluntarily contributing code sets. I don't know if you guys followed this, but Trail of Bits made wrote a lot of Go checks, and then they made them all public. And we're working on integrating that into our community registry to make sure that we give them adequate credit, so that they can feel comfortable sharing that with everyone through our community registry. So I definitely think that as SemGrep is gaining in popularity and more people are aware of it, understand the rules, so we can move to a place where whenever there's a vulnerability, like someone can write a new vulnerability found, someone can write a rule, and then everyone can benefit from that.
Well, like Trail of Bits is a great example there. Like I think that their rule set was mainly Go and Python, if I remember correctly.
Mm-hmm.
Like right there, I like some of their rules. I like, but I have a big TypeScript shop. Being able to, have that, knowing that's there and there's a contributing force or body that we can tack on that rule set very quickly and fast. And, anyways, I'm sorry, I'll pause there. But that's my biggest trouble is trying to get volumes of starter rules and find a simple way to maintain them. And the fracture across all the languages is the hardest thing to deal with right now. Yeah.
And obviously it depends on the language, but we passed 1,000 rules recently, and not all of those were written. A decent proportion of those weren't written by us. So I'm really excited about where this is going. I wonder, for people who weren't able to access the URL, is this URL that I just put in chat okay?
Seems to work for me. So.
Yep, works.
Okay, cool.
Thanks, Emma. Do we have any more questions?
I've got tons of questions, especially about linters, but I don't want to hog the whole time. I saw linting is coming soon. Like it looked like first-class lint rules are coming.
Yeah.
Or was it static config? I was my problem space. I was looking at CloudFormation templates and looking to see if I had to pull in another tool or could I use SemGrep there. And I think I saw in the future, like coming soon or in development for around linting or CloudFormation templates was one of them that was coming.
Yeah, we're definitely looking at like using SemGrep not just for code, but like infrastructure as code. For instance, we just added YAML, first-class YAML support. And we have our generic mode if you like have something simple you want to find. So that's something we're thinking about a lot.
Yeah. Is there any directional on open integration with Open Policy Agent and some of the policy as code components that they're driving?
That's an interesting question. I don't actually know the answer though. Are you part of our community Slack, by the way? Because you should definitely, if you're like,
I've just recently joined. Unfortunately, I'm about to move to Toronto, so I'm like, oh gosh. So sorry, SemGrep Slack, or are you talking about Austin's chapter Slack?
Oh, sorry, no, I mean SemGrep's community Slack.
No. But I'm in the Austin group here.
Yeah, if you'd like to join that, I'd love to share the link. And like for anyone else here who is interested in SemGrep specifically. Let me just pull that link up. Yeah, but anyone at RTC would be happy to answer those, like whatever questions you have. And also there are like a lot of community members who are really excited to help out.
Yeah. The problem space I'm running into, I was looking at is I've got the build and construction, the builder side of the equation with a lot of static analysis tools. Infrastructure as code is carrying that all the way through into my operational environment. and yet I have a whole nother rule set, language, and methodology for tracking policy as code in the operational environment. And a lot of folks are acknowledging that there is a gap here in terms of the rules are the same. They need to be the same in the operational environments, but we're having radically different approaches to them. So much so that the gaps, like I have rule sets that I think tackle the same thing. Even if I try to look at like CIS standards in configuration scanning, they end up being implemented completely different than in the actual operational runtime check tools. So being able to find one way to converge or minimize that rule set maintenance is a huge burden.
Yeah. That's I definitely love to chat more about that, especially like thinking about what our PA team is going to focus on moving forward. Don't want to take up everyone's time too. So I would definitely love to see you on the Slack and to answer whatever questions you have about our direction.
That information is in the chat here if you see that, Evan. So it's really interesting. It's also in their, I noticed their docs, it's in their support link too. It's inside there. I found that. So I was poking around too, Emma. Looks like a very interesting tool.
I'm really excited about it.
And Evan brings up a good point about the configuration side of the operations area. That is a different one, different kind of use case. Same but different type stuff.
Yeah, I don't know how many folks are in the mix of trying to operationalize and put together a whole security assurance program, but it's all those dimensions of checking the developer education and or DevOps education and the awareness. It's all of it converging together. The educational tools, the tools like this intelligence platform tools that can feed us information and teach us how to solve the problems. This is the best time to be alive in security as I look at it right now. But it's a huge challenge still to try to pull that whole ecosystem together into something that impacts all the way on the left in a very, very fluid way, but still gives us a picture of what's going on.
Yeah, I really like this about the educational because I think that's also what I like a lot about SendGrip, that the educational side can be so easily integrated into the tool and like so naturally.
Yeah.
Alrighty. I mean, Evan, if you have more, I mean, if anybody else has any questions, or you can take it up on the R2C Dev Slack channel too. You can ask them more stuff there. It's been good. Thank you, Emma.
Thank you.
Yeah,
Thank
thank
you,
you very
Emma.
much, Emma. Appreciate you speaking to us. Thank you.
Yeah, thank you.
And that'll wrap up this month's OWASP Austin, and we will hopefully see y'all next month, sorry, which is next week. So thank you very much, and next month will be Javid Malik, I believe, is our presenter.
Javad Malik, and he's very funny. He'll be an entertaining speaker, and he's quite good.
It's quite good, yeah. We're happy to have him.
Not as good as Emma probably, but
it'll be a tough case to follow here with Emma. Emma's was a good one.
Yeah, that was a right-on topic for OWASP, so appreciate you.
Yeah, I would say from the OWASP perspective, all the projects we have that are in there, I would say I would kind of figure out how SendGrep would fit into some of those, and that'd be kind of an interesting little discussion too, all the projects. So, but thank you very much, Emma, and have a good day, y'all. Have a good afternoon.
Thank you for having me.
Bye-bye.
Cheers. Bye-bye.